Okay, so today we're going to be talking about 7.6, which is exponential functions. We're going to be evaluating and graphing exponential functions. Still in A1.4.1. Okay, so the first thing we're going to be talking about is really what these look like. So if we have y equals a times b raised to x, where a is greater than, or excuse me, a is not 0, b is greater than 0, and b is not 1. So basically what you're going to have is some sort of format. For example, would be like a is 1 and then have 2 raised to the x. So a would be 1, b is your 2, and x is up here as an exponent. Now we've seen these earlier in the year, but we didn't really actually talk about them yet. But what these functions are going to look like if we were to do kind of how we should always do any type of graphing, and that is just plug and chug. Just pick some numbers. So I'm going to pick like -2, -1, 0, 1, and 2. If I pick -2, I plug it into x, I get 2 raised to the -2nd. Well, as we've been talking about, negative exponents is actually a fraction. So that's really 1 over 2 squared, which is 1/4. -1 is going to be 1 over 2 to the first, so it becomes 1/2. And then another one that we talked about was 2 raised to the 0th power, which we know makes 1. And then once we get to 1 and 2, we're really just doing typical powers, 2 to the first, 2 to the second, and then you get 2 and 4 respectively there. So if I go to my graph and I go back to, I'm going to go up 1/4 of a unit. Now I don't expect you to get that perfect, but it's right in there. 1/2, it's just a little bit halfer, a little bit more than, okay, a little farther up. So we go up to 1.5. Then we go 0, you're up at 1. 1, you're up at 2. 2, you're up 1, 2, 3, and 4. And if we were to continue this process, 3 is going to be up at 8. And it's going to get bigger and bigger. Now if we go the other direction, you're going to notice there's a pattern. When we go the other direction, it was 1 over 2, 1 over 4, okay, which the next number would be 1 over 8. So we get this graph that takes this line. It's going to be hard to draw with this. But it traces it up, and we have what we call an exponential function. Okay, exponential functions just increase upwards through the graph. Okay, so they all should look like that. And again, you can look in your book as well to see kind of a better picture. Okay, so the question is, does the table or rule represent exponential functions? So problem number 1 here. Does this represent that function? Well, if we said y equals some a, and we had some power, so we'd have to have some b to the x. Well, if we kind of dissect this, b to the 0 needs to produce a -1. Well, b to 0 is 1, so therefore a has to be a -1 in order to make that work, because b would have to be a +1. So really, if we solve for that, that's what you would get. A equals -1. So we can kind of rewrite this equation to be -1 b raised to x. And so when we go on, I get -1 and my b is still b, but now I'm going to plug in 1, which was x, and that would be b. So that means divide by -1. You get 3 equals b to the first, which b to the first is b. So 3 is b. So we rewrite the equation one more time, and I get a -1, which we'll just write -3 raised to x. And what we get is that yes, this is an exponential function because of the way the numbers lie out. 1, I get 3 to the first. 9 is really 3 squared. 27 is 3 cubed, and they all have a negative out front, making it negative. Okay, so look at this expression, and again I'll put the key at the end. Let me know what you think this one will be.